All right, let's talk about Chapter 1, Essential Ideas. This is going to be a review of what you probably had in high school, a little bit of the metric system, some measurements. Please ignore the cat in the background, and let's get started. Next is OpenStax. OpenStax is a free text. It is online. If you simply Google OpenStax, you can find it. If you're looking for any other additional material at the Alexandria campus, go to our blog site. We have everything in terms of lecture and lab on there. All right, so let's talk chemistry. Chemistry is a science. Science has gotten a bit of bad rap, because people will talk about chemicals. Well, the key here on a chemical is simply any type of matter, and therefore our entire world around us is made up of chemicals. Chemistry is sometimes described as the central science. Now, it's described as a central science because if we take and consider how chemistry relates to the earth, matter relates to the earth, we're going to get geology. If we are looking at how matter relates to living things, we're going to do biology. How matter relates to how the depth of how things work, we're looking at physics. But here in the center, we think, is chemistry. We are going to start chemistry. We have got to start with the scientific method. Now, the scientific method here is going to be evidence-based, meaning it's got to be based on what we can measure, what we can see, and once we have taken and started out with our evidence, we can take and try to get a theory, which means our nice best explanation out of what's going on with our evidence. So where do we start? We start with an observation. Observation is simply something that we see. For example, things fall. So we go and go, all right, we ask, why do things fall? And back 500 years ago, we might have said that things fall dependent on their mass. We might have said 500 years ago that things fall faster because they're heavier. Now, if that is the case, we can go to the lab and we can show it. We can prove it. So what would we do? We'd make some experiments. So we'd go to the lab and we would drop heavy things. And when we did this, we would discover that things do not fall faster because they are heavier. We discover that everything falls at the same rate. If light things fall slower, it is because they're interacting with air. So we're going to take with this and we're going to get some results. Now our results are going to start contributing to our entire body of knowledge. So we're going to continue to look at it and see what sort of testing we have. Now, once we have constant observations, we are going to have a law. Now, a law is just a statement of the results. It can be all things fall at the same rate. It can be a mathematical law. For example, the ideal gas law would be PV equals nRT. Now, that's just a statement. Now, to continue and make it bigger, we have to go into a lot of testing. And after we have testing, we can't just have a law, a little simple statement. All right, let's consider matter. Now, if we're going to talk about matter, we know matter is anything that has mass or volume. We are going to look at chemistry. Chemistry is not the same as physics or biology. We're going to look at it in a different way. We're going to start with the smallest parts that are relevant to chemistry, which is an atom. And it's the simplest type of matter with the properties, meaning that it's not going to be a proton. All protons are the same. It doesn't matter what we use to make up with protons. As soon as it becomes an entity such that it has the properties of it, we're going to call it an atom. So, for example, neon is an atom, or oxygen is an atom of a type of matter that has its properties. We're going to take and start putting them together. If we take and put two or more atoms, it can be the same type, and we chemically bond them, We attach them such that if we break them apart, it makes new stuff. We are going to make a molecule. Other note, molecules are electrically neutral. Electrically neutral means that it has no charge. So water is a molecule, but Na plus with its electrical charge is not a molecule, it is an ion. Now, an element. So we're going to separate right here elements from compounds. An element is simply one type of atom, one type of material. It's going to be made up of atoms. Now, element can be neon. Neon exists by itself. It can be hydrogen. Again, these are one type of matter, and it's going to be made up, and it can be made up of more than one atom. So the atom here is what's interesting. So phosphorus, for example, is P4. It is made up of 4 phosphorus atoms. Carbon can exist as C60. This is still elemental carbon because it's made up of simply carbon in any ratio. So we're going to have one type of matter. We know what our matter, when we discuss it, is made of atoms, and it can either be one or it can be many, but it has to be one type. If we start making 2 or more types, different elements, we are going to have compounds. All right. So in chemistry, we have to consider how we look at things because most of us, when we consider, for example, water, we are going to look at the stuff in our glass or the stuff in the ocean or even the frozen stuff that makes up icebergs. But when we look at water in chemistry, we need to go down to the smallest portions. So we need to be able to differentiate between macro, large scale, for example, the iceberg, and micro, looking at, for example, how we differentiate how the molecules of water look like when they are a gas, solid, or a liquid. This is an interesting look on the microscopic form of a single cotton fiber. So we have a nice cotton ball, and then we look at it magnified, and we continue to go down until we look at the actual molecules here, and then we go to the molecular level and see what it is actually made up of. In chemistry, we're going to mostly work down here at this microscopic level. All right, let us look at the states of matter, what it is composed of. It's physical. Physical meaning what we can look at without changing it. For example, boiling points or melting points. Chemical properties. For example, gasoline burns, and then corresponding changes that we see when we look at our matter. All right, so let's start with matter, and let's look at some options here, because whether or not we look at our options on matter, we can discuss whether or not we have a group of different types of things or pure stuff. So let's start with, does it have constant properties and composition? If yes, it is going to be a pure substance, meaning it's not variable. For example, carbon dioxide is always 1 carbon and 2 oxygens. It is a pure substance. Now, can it be simplified chemically? Can we go into the lab and break it apart into simple components? If the answer is no, for example, neon, it would be a pure substance such that it is an element. Now, if it can be broken apart into pieces, for example, carbon and oxygen, then instead of being an element, it is a compound. Element being our simplest ratio of one type of atoms. For example, O2 is elemental oxygen, but a compound is 2 or more different atoms that can be broken apart chemically. So, what if instead now we have a mixture? What is a mixture? 2 or more compounds or elements. We have 2 or more different compounds or elements, we have a mixture. For example, if we put salt in water, It is a mixture. Now we ask, is it uniform throughout? And when we say uniform throughout, we are actually asking whether or not we can see the different compounds. If we can physically see the different compounds, then it is heterogeneous. If we cannot see with our eyes the different compounds, it would be homogeneous. Heterogeneous could be chicken soup. Homogeneous could be something like air. In air, we cannot see the oxygen for the nitrogen for the carbon dioxide. So again, uniform throughout, homogeneous. Can see the different components, as in with your eye, heterogeneous. So we said that our mixtures can be separated differently than our compounds. Mixtures can be separated by physical changes. Physical changes truly almost always mean changes in physical state, as in going from a solid to a liquid. That would be melting. That is a physical change. Water boiling is a physical change. I can separate, for example, if I have a nice container of salt water, such that I have salt in some nice water, I can separate this by simply boiling this. If I take and I put a nice Bunsen burner under this, I can boil off the water. If I do that, I'm going to get a layer of salt left behind, and the key here is that this is separated by a physical change and we keep the same material. So when we separate our mixtures, so if we separate a mixture, we get the same stuff we started with. So we don't change the identity of the materials. So if we separate a mixture of NaCl and water, right here, we're going to get NaCl plus H2O, the same stuff we began with. What if we separate instead a compound? So if I have a compound and I try to separate it, so for example, if I want to take water and I separate it, now we know water is a compound because it's two or more atoms of different elements. If I try to separate this, I'm going to break it into its pieces. And its pieces here are going to be hydrogen, so let's balance this equation here, and some oxygen. This is not the same stuff we started with. That is a chemical change. Chemical change will result in new materials. Okay, we're not going to get the same stuff.